Testing. Hello, everyone. Think I should be live. If anyone's watching, I always appreciate it if you want to let me know in the chat that you can hear me, that you can see me. I had some feedback there. How's everyone doing? We'll get started in a minute. I see there's already quite a few people watching. Like I said, it's always cool to hear from you in the chat. Let me know maybe why you're interested in. Sorry, I might have feedback. Someone said they see me. Great. Then I assume you can hear me as well. And let me know in the chat if you're working on anything interesting, maybe why you're interested in ML monitoring, if you've ever done ML monitoring before. Do you have any models in production? Let me know. It's always fun kind of connecting and seeing who else is here, even from an attendee perspective. So I definitely encourage you to say hello. There's also a Slack channel. The link is in the description on YouTube. I will share a link in LinkedIn real quick as well. Give me 1 minute. The purpose of the Slack channel is it's a great place to go connect with other people, to ask questions. A fair amount of people will have questions later if you try to implement everything in your own system, and you might have an issue or just some sort of question about it, and it's a good place to ask those questions. Anyone else want to type in the chat, what you're working on maybe? Why you're, have you trained a machine learning model before? Have you put a machine learning model in production? Those are all fun things to hear about. And we'll get started in just a minute. I'm just going to paste a couple links around. The only thing you'll need to do, and I'll get into setup a little bit more in a second, but the only thing you'll need to do is create a free account on YLabs. Otherwise, you should already have a Google account. We'll be using Google Colab today to do our coding. Let me share my screen. All right. And before we get started real quick, I'll also mention we have a really fun event coming up next week on the 26th. That's kind of a whole half-day summit with Andrew Ng and a bunch of other speakers. So I pasted that in the chat, and I definitely recommend joining it. All right. And okay. All right, everyone. Let's go ahead and get started. This is an intro to AI observability, monitoring ML models and data in production. This workshop is hopefully a very friendly introduction to AI observability with kind of no previous experience expected, but definitely knowing some Python and machine learning concepts will be very helpful. But even if you're new to machine learning or programming in general, I will try to walk through everything that's happening. So we won't spend a ton of time on the ML training side, but if you've never done it before, you'll actually be able to train a model today and then monitor it as well. We'll cover some high-level concepts in like how to implement ML monitoring, or we'll cover those concepts and then how to implement them. And then just keep in mind you can't learn everything in an hour, so parts of this might be fast-paced or challenging. That's okay, but if you stick through it, I think you'll actually learn a lot. Like if you've never done ML monitoring before, even if you've never trained an ML model, you'll actually be able to go through, run the code, and get those things implemented and have a good idea how to do this in your own production environment. Quick introduction about me. I'm Sage Elliott. I'm a machine learning and MLOps evangelist at YLabs. We do a lot of really cool stuff enabling AI observability, ML monitoring. We'll talk more about that later. Over the past decade, I've worked as a software or hardware engineer or kind of ML engineer, mostly with startups and a couple agencies around Seattle mostly, and some in Central Florida. In general, I love making things with technology. I'm always doing a lot of fun hobby stuff with like robotics and things like that. So if you like that, definitely encourage you to connect with me as well. And sometimes during events, I talk fast, so I do apologize if it's a little fast for you. And then about you, again, I asked earlier while we were waiting to get started, but if you want to put in the chat, at least maybe where you're watching from. It's always fun to see where people are joining in from. And it would be great to know why you're interested in ML monitoring. And if you want to stay connected in the Robust and Responsible AI Slack, again, a link to that is in the description or in a comment on LinkedIn. And I recommend joining it and introducing yourself there as well. That way you can stay connected with people outside of just this workshop. So I'll give you a minute to type in the chat. I want at least one person to answer something. I know watching live events online isn't always the most engaging for everyone to type in chat, but I think it's way more fun if people do. Someone said they're watching from North Carolina. Awesome. Thank you, Ravi. I know there's also a little bit of a delay of me talking and it reaching the stream sometimes, so feel free to keep writing in the chat, but I will keep going as well. Setup, just for anyone who joined in. The only thing you're really going to need today is a Google account. We're going to be using Google Colab to do the programming portion today. And then we're going to use YLabs to enable ML monitoring. So you can sign up for free again at this link. The link is in the description as well, but I also posted it in the chat, so you can scroll up if it's out of view, and you'll be able to find it there. Other than that, we'll be using Colab, like I mentioned. We'll train a model quickly in scikit-learn. We're going to use an open source library called YLogs, which creates data profiles. We'll talk more about these a little bit later, and then we'll send those profiles to something called YLabs, where we can monitor them and actually have like automated alerts for things like drift detection. So what is AI observability? In general, it's a collection of all these kind of stats of areas in your pipeline where I had a different graphic before. I should probably add it back. Basically, you want to be collecting telemetry data around usually different areas of your pipeline, but there's several common areas I'm going to bring up of where machine learning models might fail or why they might fail and why you want to be monitoring them. So often you want to be monitoring your model inputs. You have things called data drift or problems with data drift, data quality, schema changes. We'll go a little bit more into these in a second as well. You want to be monitoring your model outputs. So you might experience something called concept drift where your model's just not performing as well. The volume might have changed. And then you want to be monitoring your model performance metrics. So things you've probably heard of before if you've done machine learning model like accuracy, precision, recall, these things over time. And then obviously business KPIs. If you're just monitoring everything else, but you don't actually have a business value, then machine learning might not be working for your company. We always have a saying, we like to say bad data happens to good models. So your model can be trained and be working perfectly, maybe even when you first put it in production, but typically data kind of shifts over time in the real world. And so you want to be kind of monitoring all these different things to enable a reliable machine learning system. Has anyone experienced any of those issues I mentioned before, like data quality issues or data drift? And it's okay if you don't know what they are. We'll go over them very briefly. But it's always fun to hear about people's experiences if you're willing to share. You don't have to share a lot of details or anything, but do you have an example of where maybe something changed when you put a machine learning model in production and it stopped performing as well as you thought it would? And I see other people talking in the chat, saying hello from Switzerland. That's awesome. Argentina, another North Carolina. Someone said they just started to learn ML, trying to absorb as much as possible. And they're from Romania. Awesome. Thank you. Thank you for putting the chat. It always makes it way more fun for me presenting as well. So I'm not just talking to myself. At least I get to see other people are watching. All right. So I'll go into some data quality examples, maybe where an input sensor is damaged, causing bad data. Data was manually entered incorrectly. A lot of times you might be just reading in like these CSV files and someone had to manually enter that data and things can go wrong there. If you're doing something with computer vision, the camera could have moved and been pointing the wrong direction, or someone could have turned out a light if it was a camera in a manufacturing factory or something like that. A schema can change, so a software library might update, or even on a hardware device like a camera, And then the outputs are formatted a little bit differently before. And if you didn't account for that in your pipeline when you updated that software, there could be some major issue now with your data quality. And basically, anywhere that you do an exchange of data or transform of data in your pipeline, anything potentially could go wrong. I know I've had that mistake before where I've read in data and I was pretty confident I was doing it correctly, and I did not. And so having something kind of looking at all those different steps to make sure that the data is behaving or matching what you think it should look like is pretty important. Does anyone have a example they want to talk about of like a data quality issue? I think it's always fun hearing about some sort of example where you've seen this. I've done a lot of work in computer vision. I might have mentioned before, but so yeah, I've seen things where like I mentioned a light going off in the factory where you think that you're setting up a camera in a pretty controlled environment, not outside, it's in some manufacturing floor, but there's always these little things that could go wrong. Data drift. So a example of data drift is when the input data for predictions are no really longer close to the original training data. Is kind of how I like to think about it. So you have some distribution of data, you trained your machine learning model on it, and now you have this deployed somewhere, and the data has shifted a little bit, or sometimes a lot. And that could be from like seasonality changes. You could have a new group of users starting to use your data. The consumer preferences might have changed. And again, if you have any examples, let me know in the chat if you've experienced data drift before. So seasonality is one I like to talk about as well. And again, like I mentioned, I've done computer vision, so those are often things that come to mind for me. And I think that they're good examples for a lot of people if you haven't done a lot of machine learning because it's so visual. But you could think of if you trained a machine learning model or a computer vision model in the summer and only had summer data, and this could be, you know, animals outside, it could be people inside. So for example, like let's say if you've ever gone to Amazon Go, it's a grocery store where it uses computer vision to track people and what they pick up. Well, if it was only trained on summer data, all their clothing is going to be completely different probably than winter data. So the people might have bigger hats, coats, and things like that. If you trained it to detect people only in summer clothes, there's going to be this kind of drift of data of like what people might look like. And chances are that it wouldn't be performing as well on that because of that seasonality drift. And again, if you have an example, throw it in the chat. A quick example of concept drift. So incoming data didn't change, but the output no longer is giving us the results we want. One example I like to use for that is the housing market. Let's say you had a very simple model and you're just using the number of rooms and square footage of the house to make a prediction of the price. Well, if you train that, 10 years ago, 20 years ago, the input data isn't changing. It's still the number of rooms, it's still the same square footage. But if you didn't train your model with the recent prices, it's still going to be predicting those older prices. So this is kind of an extreme value or extreme example of a concept drift where your model really no longer maps to relevant outputs anymore. So input data isn't shifted, but over time, the real world results have. COVID-19 is a good example that caused a lot of data drift and concept drift. So a lot of behaviors changed and a lot of things went way up in value. And again, I'll ask you put in the chat an example that you've seen in the past. And all right, just one more slide before we're going to get into the more hands-on portion. Some other areas of data and ML monitoring that you might want to keep in mind. And I will do workshops and material on these a little bit later, but model explainability. So there's great libraries and stuff where you can track, feature importance in your machine learning model and understand a little bit more why it's making those decisions. And then bias and fairness is one that's really important. You might want to be able to segment up your data and monitor in ways where you can see how it's performing on specific classes. And I'll talk a little bit more about that later if we want. But for now, we can go ahead and get to the more hands-on portion of this workshop. But I will say if you have any questions, put them in the chat right now, and I'll have a minute to look at them while everyone's opening up their notebook. And the link for this should be in the description on YouTube, where most people I can see are watching. If you are on LinkedIn, I put it in a comment, so you should just be able to scroll up if you don't see it and open it that way. I'll share it again in a comment here on YouTube as well. So you'll want to open up this Google Colab link. And then also you'll want to sign up for a free YLabs account. There's no card or anything required, so it should be very easy. Those are the two things you'll need to kind of run everything in this workshop. So once you open up that Google Colab link, you'll have something like this. And I want you to go to File and save a copy in Drive. This is going to give you your own copy of this code. So you can mess with it as much as you want. You could try and experiment with it, and you can always come back to this original one and create a clean copy. And while you're doing that, I'm going to catch up on chat real quick. So everyone, open up that link, go to File, save a copy in Drive. Someone asked, how much mismatches must there be before you confirm that there is data drift? So that kind of depends on how sensitive you want your model to be. And we'll actually see this, I think, a little bit better when we get to the hands-on portion. So you can kind of pick how to look at that and tune it, right? So sometimes this might depend on, your application, like how severe it would be if the data drifted. So you can think of like if you're doing something in a self-driving car or a medical field where it's more important that you detect this drift and you'd rather get an alert about it and it actually be okay versus not getting an alert about it. So you can actually tune the sensitivity. It's kind of like if you're tuning an ML model for higher recall, right? Like you'd rather have a false positive so you could double check to make sure it's true. You can think about it similarly for data drift. So was everyone able to make a copy? I'm going to go ahead and make a copy myself. And if you're new to Google Colab, it's essentially Google's way of hosting a Jupyter notebook in Google Drive. It's really cool. If you've never used a Jupyter notebook before, it's a great way of being able to write code, text, output, visualization, kind of all in one place. So it creates this really cool document that's interactive, and we can do most of the stuff we're going to be working on today in here. Also, I'll just give them a quick shout out. You don't need to do this for this workshop, but you can go to runtime, change runtime type, and they actually give you a fair amount of GPU computing time. So if you're getting into machine learning or deep learning, you've never done deep learning before and you don't have a GPU at home, you can actually use Google Colab. It's a great way to get started. And all right, so again, you'll want to create that free account too, as well if you haven't already. There's a couple other useful links in here, and then we'll talk about them as we go a little bit more. First of all, let's go ahead and run this first code cell. Now, you can hit this play button, and this will run the code cell. You can also hit Shift-Enter when the cell's highlighted. So if you don't see me clicking that play button, it's because I'm hitting Shift-Enter. Once we run this code cell, it might take a little bit to run because it's kind of initializing the whole environment for us, and it actually gives us a whole little Ubuntu instance here, so you can actually run bash and terminal commands. This is just kind of listing everything in the directory. You can see there's a folder called sample data. So it's really cool that you can code in here. You can also do some terminal commands. That includes installing libraries. So one thing I didn't mention is Google Colab actually comes pre-installed with a whole bunch of libraries as well. So it actually has things like TensorFlow, PyTorch, scikit-learn, all these very common machine learning libraries pre-installed. So the only thing we need to install here is the YLogs package, which again we'll talk about in a little bit. But it's going to be what we use to create data profiles. We're going to profile our data sets. Then we're going to look at those profiles and measure them for data drift. And I linked to the GitHub here as well. Actually, I'll paste it in chat. And if you want to give it a GitHub star, that's always appreciated. It's also linked in the description below as well. So everything, I think most links I talk about are in the description, at least the main ones you need for the workshop. All right, so we've now installed YLogs, and we just passed in a couple variables here to make sure we get all the dependencies to write to YLabs, as well as use the visualization component, which we'll see in a minute. So let's go ahead and import our libraries. We're going to import YLogs as Y, NumPy, Pandas, Datetime OS, and then some stuff from scikit-learn. Let's go ahead and get this iris dataset. Don't worry. We're just going to quickly train a model on the iris dataset. It's not going to be the main part of this course. So if you've done a lot of courses or anything before, you've probably used the iris dataset a lot. We're just going to quickly train a model on it, and then we're going to get to some data with issues and monitor that data. So hopefully it'll be more interesting than just going through the iris stuff again. We're going to quickly train a model. Again, if you're new to machine learning, I'll just go through real quickly what's happening here. We're importing a KNN machine learning model. We're getting the feature values and target values from the iris dataset. So the iris dataset has the sepal and petal length and width values, and then we're just going to train a model to predict what class of flower it belongs to based on those 4 features. We're just going to do a train test split. That's where we split up the dataset for training and testing. And we're going to pass it some values, say use 70% of the data for training. We're going to stratify on Y, so we try to get an even distribution of the target values in our model. Then here's where we actually do the training. So we're going to pass in the X data and Y train values. And then we're going to do some prediction here. And then we're going to test the score between that prediction. So our model here, just based on that amount of data, we're at a 97% accuracy score for how our model's doing. And just a quick intuition, this is going to come up when we kind of debug our ML model later, is if you don't know, so this is kind of how a KNN model works. Actually, let me zoom in a little bit for you all. Is that better? I don't think anyone mentioned they were having issues seeing, but that was probably a little small for you. Just a quick overview of how a KNN works. You get a new piece of data, and then we have this hyperparameter we change here. So we're actually looking at the nearest 5 neighbors for our model here, but this example, it's looking at the nearest 4. We get this new piece of data, and then it looks at the closest 4 neighbors of that are closest to that new piece of data. In this case, 3 of them belong to Versicola, 1 of them belongs to Virginica. So it's going to predict that the class is Versicola. So just think of this as you get a piece of data, you look at the X number of closest values or closest classes to the relation of that new piece of data, and that's going to make a prediction of what class it belongs to. So quick intuition, just because you will see a little bit later that something might go wrong, and we want to understand why. So it's good to have an intuition of how these ML models work. Just one other cell of setup, really. This looks a little ugly. I'm just importing in some CSV files. We're going to create some variables here that is just, batches. What we're really doing here is just creating a batch of data frames, and we're going to use it to simulate like we're running a model for days. So I'm just creating several days of data here that we can run predictions on. Nothing fancy. It looks kind of big because these are all separate CSVs right now. And if we look at what the CSV looks like, here's an example. So we have those 4 features we talked about: the sepal length, sepal width, and petal length and petal width. And we see some values. So we're going to use these to make predictions. All right. Any questions so far? We're going to get into the fun part now that we kind of went through the setup, but I will pause if anyone has a question. And I'm going to get a drink of water. Again, I know there's a lag, so feel free to ask questions, and if I see them, I'll try to get to them as soon as I can. All right, so we're going to create a log with YLog. So YLogs is an open source library for logging data pretty much of any kind. We have examples using it for computer vision, which is really cool. With YLogs, users are able to generate summaries of their data. We call those YLog profiles. So the summary, we'll see what this looks like in a second, but one key thing to note is these are just lightweight statistical summaries of your data. So they actually don't really contain any raw data. You could think of this, and we'll see it in a second, but if you're doing tabular data, you have things like the min, the max, the medium of your data set. And we use things like that to actually detect data drift. And one cool thing about this is, 1, it's very lightweight. 2, it's very secure, so you're not really passing raw data outside of your environment. And this is really important for a lot of industries, but I mean, everyone should have security in mind. But for, in particular for like healthcare and finance industries, this is something that actually is really cool for that. So just with those lightweight profiles, we're able to track, changes in the data set. We can create constraints. We'll talk about this a little bit later, just even in the open source library. This is kind of like a little unit test for your data. And then we can quickly summarize, a whole bunch of key summary statistics about the data set. We have a whole bunch of integrations as well. So we work almost in any Python environment. I even put it on a Raspberry Pi the other day because I'm building like a robot project with it, which is really cool. And so let's go ahead and run this and kind of see what the profile looks like. Here's an example of running it, kind of a clean example. It's only a few lines of code. Let's go ahead and just run these code cells though. First, we're going to do a quick setting in pandas just so we can see all the columns in a data frame. Now we're going to set variable profile1. We're going to create a log with YLogs. We're going to call y.log, and then we're just going to pass it a data frame here. So you can easily create logs on data frames and dictionary objects. And then we're going to get the profile view and then view it in pandas. So we saw kind of what this data frame looked like. And now we can see the profile made from this data frame. So we can see the estimated cardinality is 300. That kind of means we think there's around 300 unique values in it. And the reason why it's so high is if we look back at this data frame, you can actually see these are really long float values. So these are all actually probably unique, which sounds right because it says there's 300 unique values in there. We get a count of numbers, so we can see that there's 300 numbers. It would also count if it's not a number or null. You get distribution metrics, like I was saying, the max, the mean, the median, the min, different quantiles, standard deviation. And then you have some other things of like, what types are these? Is it a fractional? Is it an integer? Is it an object? Is it a string? So, right, this is a pretty lightweight summary of our data. And you can see there isn't really any raw data in here. It's just kind of these statistics around the data frame that we passed it. So this is really cool. This, like I said, it's super lightweight. It is pretty secure, or very secure. Like there's just in terms of not having raw data in it. And with this, you'll be surprised potentially about how much we can actually catch about our data, which is really cool. And if you want to learn more about YLogs, there's a ton of examples in there as well. So again, you can click on these links, go to the GitHub. There's a lot more in there. All right, so now we saw how to create a profile, but let's go ahead and look at how to do more fun things with those profiles. So we're going to write one to Ylabs, and then a little bit later, we'll actually be looking at just some more stuff you can do with the open source project itself without writing to Ylabs. Ylabs is the observability store where you can actually take these profiles, write them up, and then quickly like visualize them and set monitor alerts. So instead of inspecting them manually every day, you can see when your data drifts. So let's go ahead and do that. What I'm going to do is go to Ylabs, and hopefully you already made an account. I'm going to go ahead and log in. So I have a couple projects in here already. I'm going to go ahead and delete this one. I'm going to hit create project. And then I'm going to hit set up model because we're going to be putting in our own data today. If you wanted to, you could also just add some demo data. But I think it's way more fun to understand how to put your own data in here. So let's hit set up model. Give this a project name. I'll just call this Iris Jan 17. You can call it whatever you want, or just call it Iris. And then one important thing that I'm going to do, you can edit this later if you don't do it now, but I'm going to set this as a classification model. This is just going to be important when we pass in ground truth values. We'll be able to get some metrics around our model performance, and it'll know it's classification or regression. So hit create project. Then you'll see this model number generated here. So mine is 76 because I've created a fair amount of models in here. Yours will probably be model 1. But copy that number right now. And we'll scroll down. So we're just doing a little bit of setup before we can write those profiles to Ylabs. And I do have instructions on how to get those tokens here as well, if you're watching this later. But now we have our model ID, so I'm just going to paste it into this variable here. Now, I accidentally copied over an extra space. If you do that, make sure you delete it. You don't want any spaces in any of these keys. So then we want to get our API key. So I'll go back to Ylabs, and I'm just going to hit this Access Tokens tab. And if you are on your homepage, you need to get here. You can go to Settings, go to Access Token here as well. So I'll create a new token. I'll just call it Jan17. I'm going to copy this token over. API key, no spaces, good. And then I'm going to go get one last thing. I'm going to get my org ID, which is also on this page. So you can see it's listed here. And it's also listed down here as well. So I'm going to copy this org ID, paste it in, and then we're good to go. That's all the setup we have to do to start writing our profiles up to YLabs and monitoring them. Let me know in the chat if you did this. Once you do it, you can hit run, and we didn't get any errors. We should be good to go. Did anyone copy their values over? Do you need me to run it through again real quick? Let me know. Someone said copy. Awesome. Thank you. Again, thank you for letting me know. It's great having a little bit of feedback, a loop from anyone watching. So now let's go ahead and import YLabs writer. And you might see just a little warning. That's fine. It's just saying we don't have the proper library called pill, which we don't actually need for this workshop. That's just for image support. So we're not going to be doing images today. One thing to note is Colab, like I mentioned, has these pre-installed libraries. So sometimes they'll have like an older version or a newer version that won't work with some other library. So you can always pip install it if you need to. So now this is an example of how to write a single profile, and then we'll backfill data, and it'll be a little bit more interesting. But I want to show how simple it is. So it's just 3 lines of code here, where we're just initializing the YLabs writer. Then we're creating a profile like we did that we saw before, and then we're just saying write that profile up to YLabs. So if we go to YLabs, go to our homepage here, we'll see there's a little check mark. We also see that there's a profile lineage here. You can click on that. That's just saying that, there is profiles written for these dates. And if we click into one of these features, and again, we'll look at this more in depth in a second. I just want to quickly show that, it's just a few lines of code there, and we got a profile written, and we can see that it has those statistics that we were looking at in the profile before, such as like the median, the max, the min, and those quantiles. So let's go ahead and go back to our profile. And what we're going to do in this next cell is kind of simulate writing these profiles over several days, or you can backfill data. So you might have already had an ML model running. You want to backfill data into YLabs anyway, or you could think of this as we're going to run our model for like 7 days and monitor the output of it. So all we're doing here is just what we did above, except for we're looping through each of those data frames that we created in a list before. And then we're changing the date time. Basically, we're just saying, for 7 days, add a different date here. And by default, the date time of your profile will be the time that you write it up, but you can always overwrite it. So like I said, if you're backfilling data or you're saving data locally for a while and then you're going to write it all up at once, you can manually change the date time of that profile here before you push it to YLabs. So let's go back to the platform, and I'll click back on the home page, and we see we have our Jan 17, and we can actually see now, if you look at this little profile lineage part, that it goes from 110 to 117. So let's go ahead and just click on it, and it's going to bring us to this input view very quickly. I guess we can explore these tabs real quick as well. So you have a summary tab that's going to have, a quick summary of what's going on and if there was any alerts detected. You have this profile tab. So we'll talk about comparing profiles with just the YLogs library a little bit later. But you can write the profiles up, and you can actually kind of compare the distribution here. So you can see these look pretty similar distribution-wise. You can click in, get a little bit more details about them. This is kind of overlaying those 2 data points. So we can actually, these are very similar. Let's see if there's one with a little bit of drift. There's some that have a lot of drift, so we'll see in a second why it might not be good to overlay them. But you'll see there's whatever's going on with this one looks way different than the distribution of those other ones, and we'll see why in a few minutes when we get to it. But so you can kind of compare these profiles manually here. It's a cool way of visualizing it. Let's go back to the inputs tab, and we see we have our 4 inputs, those petal and sepal length and width. Let's click in. I guess I can mention here too on this little page, you get some summary of what's going on as well, like total count, did it go up, what does it look like, estimating unique values. So let's go in, and here we can kind of quickly view what our data looks like. These are all pretty similar looking trends, just the way we created this data. But you can see if I just hover over this manually. Like we had that one profile before, now we have these profiles until the 17th. And you'll get a little information in that box that pops up. It might be a little small on my screen, but if you're following along, you should be able to read it just fine. We see things like this medium, the max, and min. So let's look at this first profile. The medium's 4. The next one's still 4. It's all 4 something. And then all of a sudden, the median here pops up to 8. And that max value went up quite a bit as well. So we think maybe something's happening there. And this one at that top of the pyramid looking thing, that's all the way up to 100. And then this one after is 0. And all these other ones kind of go back to normal distribution. So do we think something might be happening here? Maybe the data's drifting a little bit? I would think so, just from manually looking at this, that, right, like comparatively, all these other ones are pretty close to each other. And then all of a sudden there's 3 here that look quite a bit different than any of the other profiles. Does that seem like something might be going on? Chances are probably, right? Now, it's cool that we can manually see this in this nice dashboard, but let's go ahead and set up a monitor. So you can click on this little button here. This will bring you to this page here. You can get really customized with your monitors. So I'll show you real quick. There's like a whole area where you can edit JSON and tune it exactly how you want it. But for a lot of people, having these presets works just great. And we can, let's look at them real quick before we enable this one. So we have ones for data drift, data quality, model performance, and we have a lot more coming soon. But let's go ahead and enable this one for data drift, and then we'll look at what it's doing in a second as well. So let's hit enable with one click. So this automatically just put this in our project here, and it's going to model for data drift. And what this says is, compared to a trailing 7-day baseline. So let's go look at what this monitor is actually doing. I'm going to click into the monitors here. It'll show all the ones enabled. And I'll hit this edit monitor button. So you can do a lot of customization just in the UI here. So someone had mentioned earlier about, how sensitive should it be? And I said that depends on your use case. So you can actually adjust the sensitivity in this monitor here. So this one is detecting drift on your input features. We can see here some options is, do you want to analyze the entire data set, or do you want to do segments? So I mentioned there's a way of kind of slicing up your data and segmenting it out to look at specific classes or features and see how your model's performing. So it's a good way to see if it's biased. Like if you're making predictions on someone's zip code or something like that, that shouldn't be allowed in certain industries, you can see kind of what's going on there. And here you can adjust something called Hellinger distance. This is basically how you would tune how sensitive your model is in YLabs. So we use a Hellinger distance metric to monitor the drift. So we can make this more or less sensitive, and we'll see what this looks like in a second when we actually run it on the input. But essentially, you can put the tune this up or down. Now, when we hit one click, by default, it's doing a 7-day trailing window. So we saw there was that spike happening in our data, and the way this is going to work, it's going to be looking at these last 7 days and kind of see, is there an anomaly happening in those last 7 days? You could adjust this. So our data only goes to 7 days right now. But if you had a model in production for 90 plus days, you could have a trailing window looking at the last 90 days and see if there's any big anomalies happening there. Otherwise, you can set a specific date range, or you can set a reference profile. So what I like to do is when I'm first putting a model in production and I don't have any production data yet, I'll actually usually upload a model or a reference profile with just the training data set. And then I can compare any new data coming in to the distribution of the training data set and see how much it's changed. The rolling window is nice because you'll capture a little bit of like maybe minor drift. So you wouldn't expect your distribution usually to exactly match your training data. So having a rolling window is kind of good for catching like some minor seasonality type changes that could happen. And then you can set up, do you want to be alerted by Slack, email? You can also set up a PagerDuty integration. So if you want to do any automated workflows when drift is detected, you can do that as well. And then you can set the priority of like low, medium, or high. So let's go ahead and we'll go back to our inputs tab. And let's click into the pedal length again. So now we have this button that says preview now. Let's see what the looks like when this monitor would run. By default, the monitor runs every 24 hours. So you would write data up, and then every 24 hours, it'll run this monitor and see if there's any data drift detected. So let's hit preview on this. And here we go. So we have alerts for those 3 profiles that when we were manually inspecting, we thought they looked a little suspect, right? Like it went from, these lower numbers of a max of around 6 or 7 to all of a sudden of a max of almost 12, over 100. And then this one's really interesting because everything is 0. What do you think that everything 0 means in our profile that we made? Let me know in the chat. Were you able to set up this monitor? Did you get any of these alerts? And does this seem interesting for maybe any project you've worked on in the past? So we mentioned data drift and data quality issues at the beginning. Can you kind of see how you might set up this tool in a project and catch when some sort of anomaly happens with your data or with your ML models so far? And so far, we're just looking at input data. We'll quickly look at how to do output data and performance as well. And I see a big spike of people joined in. So everything, if you want to try to catch up, the links are in the description below. The main thing is you just want to sign up for a free YLabs account and then open up the Colab notebook and make a copy in your drive. Did anyone get this far following along? Any issues? Anything you want me to go over again? I know it's kind of fast. It's like a crash course on how to do this. All right, I'll keep going then, but let me know in the chat if there's anything you want me to come back to. Also, we'll quickly finish up some of this stuff in the YLab, so it'll be a little bit more open for questions as well. So let's go back to the notebook. Now we've written all of our input data in, and this is a how you would write a reference profile, so it's very easy. Like I mentioned, if you want to compare to a baseline like on your training data, you can do it with just, again, like 2 lines of code here. So let's go ahead and log the model output. So we just looked at the input so far. Let's go ahead and here we're just quickly adding the prediction outputs from our model to a pandas data frame so we can actually see we had our class output and then the probability that it thinks it belongs to that class. And then we're going to do exactly like we did before. We're going to loop through all those batches of data, and then we're just going to log the prediction with the time again. And but this time we're just passing in the new values of class output and probability output. And I'll just quickly mention, most of the time when I've done this, I actually set it up in a project, like on an API or something like that. I would log the input data and output data in one call. So here I just kind of broke it up because I think it makes it a little bit easier for the workshop. But typically you would probably be getting your input data, making a prediction on it as it's coming in. And then so you could just log those in one data frame or one dictionary object, or even just write it up as they come in basically to Ylab. So just quickly calling out that they don't have to be separate steps, but they are here just to break it down a little bit. So let's go back to Ylabs. And we see we actually have this input tab and an output tab. So to get data written to this output tab, all you have to do is include the word output in your feature column. So that's why this is called class output and prob output. And let's go look at that. So very similar to our input tab. Again, the only difference is like having these separated can make a big difference when you have a ton of features or outputs. And so in this case, when I had 4 features, it would be kind of easy to see them down here, but you might have hundreds or thousands of features in your model. So let's go ahead and look at class output real quick. What's going on here? So we can see that, these first 3 days, it was a pretty even distribution of all these different 3 classes for our flowers. And then all of a sudden, on day 4, 5, and 6, they all look like they're only predicting one class. And then it goes back to normal in this profile. Does anyone have an intuition of why this is happening? And as a hint, it goes back to kind of how KNN works when I mentioned it at kind of near the beginning of the code portion. And while you're thinking about that, let's also look at the probability. So we can see probability score kind of varied quite a bit from these first 3 days. So we can see, again, the min-max situation. So most of them were probably around, close to 100% score, but then we had a few that it was a little less sure on. And then all of a sudden on those 3 days again, we look like it's incredibly confident. It's 100% sure on all the time that it belongs to these classes. And then it goes back to a little bit more of a varied distribution again. Now, again, any idea why it might be so sure that in this case those features belong to these exact classes? And this is interesting too, because in this case it's a KNN model, so knowing how it works, it's interesting because looking at the score get more confident is actually a sign that something might be wrong. So if we go back to our notebook, kind of look at that quick little chart of KNN. So if you had a new piece of data here, right, and it's looking at the 4 closest neighbors, and it's making a prediction that it's Versicola, makes sense, it's close to it. What if we had a new piece of data down here? Cool, the 4 closest might be Setosa, makes sense. What if we had a new piece of data that was all the way up here by this profile picture on the distribution? What do you think would happen? Well, we don't have any data quality checks on our data right now coming in. So by default, it's still going to look at the closest 4 neighbors, even though it does not match the distribution at all. So if you had a data point way out here, the 4 closest neighbors are still, in this case, Virginica. If you had data over here, so we actually know that some of our data in the pandas data frame was zeros, even though a petal length should never be 0, it's still looking at the closest 4 neighbors. So in this case, it would be Setosa. So it's actually interesting because the data is so far out of distribution, but in this case, still looking at the closest neighbors, that it's way more confident. It's actually like, well, I see nothing else except for these classes, so I'm going to predict that class. So it's actually interesting that using this YLabs dashboard, if we didn't know that, if we didn't actually have access to the raw data the second, we can kind of put together, there's data drift happening in the inputs tab, and then we have our our output logs, and we can see, well, this is interesting. There was distribution on most days. All of a sudden, the distribution between predicted classes changed quite a bit. And then on those same days, the probability also changed quite a bit. So this is very interesting. There's all these different places we can look at. And we can use this kind of debugger model for those things we talked about at the beginning. So when we detect a data drift, we can set up a monitor for some other features as well. But then manually going through, we could see that something definitely is wrong on those last 3 days, and we might want to go get that data, maybe annotate it depending on what we're doing, and then retrain a model on it, or set up tests for our data. So in this case, we caught it because we had YLabs, but maybe we don't want to do a prediction if the petals are 0 or some number that's outrageous. And I'll actually show you how you can use YLogs just in your environment to do that in a few minutes when we're done with this section here. So let's go back to the notebook, and we'll do one last thing in YLabs for now, is we want to log our performance. So in this case, to log our performance, we want to get ground truth values. How you get ground truth values is usually have someone annotate it, or you have the values when you get the data. So someone said, yes, this actually belongs to this flower or not. So here we're just creating a pandas data frame. Now you can see that we actually appended the ground truth value here. So in this case, like we can see the predicted class was 0 and the ground truth was 0 in that case. So that's correct. Then let's go ahead and update or write these to YLabs. And it's very similar to how we wrote the other profiles up, except for in this case, we're calling this y.log classification metrics. If you're doing regression, it's y.log regression metrics. We're passing in the data frame, and then we're just saying, these are the 3 columns we need to calculate our classification metrics. We need the ground truth column, we need that class output, and then we want that probability. And then again, I'm just manually setting date times here. But same thing applies, that it would just have the default date time. And let's go back to YLabs. go to our Performance tab, and now you'll see we only had a few profiles there, actually, that had the ground truth on them. But you can see that the accuracy or recall and all those different classification metrics are tracked over time. You even get a confusion matrix as well down here. The cool thing is, though, like I mentioned, you could have that drift happen, and then you use PagerDuty to maybe even trigger off an event to have annotators come in and annotate that data, then log it up as the ground truth, and then see how much your model or concept drift could have actually happened in your model. Like I mentioned, you go to the Monitor Manager, you could go to these presets, and then you could also have a monitor on your performance metrics. So if you have someone actually logging the ground truth and calculating these performance, you can also get some sort of message when something like recall or precision drops drastically. We also have the Segmentation tab, and that's where I talked about how you could segment up your data and track specific like classes or how it's doing on specific features. That'll be for a different workshop, but if you have any questions about it or you want to get started, let me know in the Slack channel. And then also you can see there's a whole example notebook here if you want to get started with segmentation right away. And we can go back to the notebook, but first of all, I know there's still quite a few people here. So how does this feel? Does it seem cool? Is it an interesting project? Are you going to use it? Any questions? Does this make sense, the kind of stuff we're tracking right now, like seeing, the data changed, getting these automated anomaly detections, tracking the output, how you can use that to kind of trace where your model, is failing? I'm gonna assume you're loving it then from your silence. But let me know in the chat if you have any questions, or if you have any questions later too. Again, join the Slack channel and feel free to message me there later, especially like if you're just kind of watching this now and then you actually want to use it on a project or data in the future. That's going to be a good place to stay connected with me. All right, so we can go back to the notebook real quick and we'll wrap up a few things. I'm going to go pretty fast because we're almost at the hour. But I just want to show some other cool capabilities of YLogs that you can use even without YLabs here. So YLogs, again, is the open source project that you can create those profiles with. And like we mentioned, in our case there, we didn't actually have anything checking our data. So we were making predictions even if our data was well outside of the distribution of our training data, or it was even zero. So we can actually monitor for data quality and do something like essentially just validate the data coming in before we even did a prediction with something called constraints in YLogs. So here we can basically, let's just go ahead and create a whole bunch of these profiles with YLogs. We're just passing all those batches we used earlier. We will create a view again just to kind of reiterate what's going on. Oh, and I forgot because now I added the classes. So you can actually see the cardinality is different now on the class output. There's 3 unique type values because those are the 3 flower classes. And then here we can still see the cardinality is 300 on our other features, just like it was before. So go ahead and build a constraint real quick. We're going to import some constraint helper functions from YLabs or YLogs. And then you can go ahead and run this. We're going to initialize our constraint builder. Then we're going to pass in basically 4 things here. The first is the name. So you can give this a name. I like to call it whatever it's kind of actually doing. So here I'm saying string type is equal to 0. And then here we have a lambda function where we're saying, the x string value should equal 0. And that x value there is coming from, we're saying go look at types in the YLog profile. And then specifically in this case, go look at the petal length. So if you go scroll back up to this profile and we scroll over to the right, we have this types and then string. So basically we're saying type string should equal 0. And if you run this, you get an output that is like a name and pass fail. So let's quickly go through and look at what this would look like if we had 4 of them. Here I'm saying basically that the petal length should always be over a certain amount and under a certain amount. So here, I think I messed up with the name here, but it's actually looking, it's saying the amount should be always over 0 and it should be under 15. And then we're going to be looking at the distribution, and we'll look at petal length and all the different features here. So we scroll back up, we can see in distribution, I think we were looking at, I think it was max and min in that case. So you can see, right, like we always want this to be under or above a certain value. And we can run this. We get this whole little report here with this pass-fail metric. And this is kind of hard to read. So basically, this is the string. Or it's hard to read as humans if you have a whole bunch. And then we're saying, you know, 1 in this area is fail or pass, and a 1 in this area would be fail. But we have this cool visualizer function for this. So if you have a big report, that's what I do. I didn't run that cell. So if you have a big report with a whole bunch of features or constraints on all of your stuff, we have this nice, really clean way to read them and see if they passed or failed. So it generates a whole report. You can even search. You can also do a filter for them as well. And then we have a function where you can basically just look at all of those, and if they all pass, it'll return true. If one of them fails, it'll return false. So you can actually just kind of automate, like, hey, did these all pass? Great, now go run this prediction on my model or do something with it. Or did they fail? Alert me, do something in that case. So again, if we ran this on a different profile, we actually see that they all failed. This is probably the one with all zeros or something like that. And if we ran that, again, it returns false. So we wrote these kind of like, essentially, I like to think of them as a unit test for our data. And then you can pass fail them and do something based on that. So yeah, if we looked at this one, yeah, this is the one that was all 0, so that's why it failed there. And then real quickly, again, I know we're almost at time, so I'm going to power through this, but if you do have any questions, I'll stick around for a few minutes as well. And then again, you can ask in Slack as well. But so we're going to use the visualizer function in YLogs to kind of do some of the stuff we did in YLabs earlier, where we're going to plot kind of this data distribution over each other. So we're going to read in a target profile and a reference profile. So those are going to be the 2 that we're comparing against. So in YLogs, you can compare 2 profiles at a time. And let's go ahead and look at this drift report. So this is kind of like the view that we saw in YLabs. With just 2, we can see the distribution. Here, they probably look pretty similar. We have this p-value score. The higher this p-value is, the closer the distribution is. The lower it is, the further they've probably drifted, or the further they are from the distribution that you're comparing against. And we can plot the histogram of one specific feature. So here we're plotting petal width on each other. And we can see they're very similar, right? Like the distribution's almost identical. This other one, they're even more identical. So that's why the p-values were so high. Let's go ahead and look at a different profile. So we can see that the p-values here are incredibly low. So that means they're probably not really overlapping in values. And if we do the same thing, we're visualizing the distribution of those 2 profiles. We can see that they are not overlapping at all in this case for the sepal width. The min value here is 6, and the max value is like 10 or 11. And here it goes from essentially 1 to 4.5. So you can see, you can kind of visualize and get these values of how much your data might be drifting or how different they are kind of directly in your environment with YLogs. And again, there's more links if you want to play around with the these features. They go way more in depth, like in this blog post or in the examples in GitHub. So I know we're kind of exactly at that hour point now. We covered a lot in a short amount of time, so I hope you learned something new and useful. And are you going to start implementing AI observability into your projects? Let me know in the chat. and let me know what you thought of using something like YLabs. And maybe if have you used something like that before, or are you gonna implement in your project now? Give it a try, even if it's on kind of a hobby project. It'd be cool to hear your thoughts. Oh, and then there's also a link. It should be in the YouTube description as well. There is a form you can fill out if you want a certificate for attending. You can fill that out. And we'll also send an email out about it as well. And the main thing, obviously, is to keep learning. So there are a whole bunch of resources that were throughout this notebook. Also, you can just go to ylabs.ai or check out the YLogs GitHub, again, in the description. And I know I shared it in a comment as well. And everything we used is kind of in here at the bottom. I will share the Slack one more time if anyone wants to join there. And if there aren't any questions, I'll probably go ahead and end the stream. And we can, if I missed one or something, also I'm using StreamYard, so I think all the comments should come over. Occasionally one might not if you asked on LinkedIn or something. If you did ask questions, I'll follow up if I didn't get to it. Well, thank you everyone for attending. It was really fun. I see some people saying thank you. Awesome workshop. I'm glad you enjoyed it. Yeah, let me know if you have feedback for using YLogs and YLabs as well. Let me know. Again, the Slack channel is the best place, or you can connect with me on LinkedIn. I'm pretty active there as well. But with that, I think we are at the hour. I know I have some other work to do as well. And thank you everyone for attending. And it was great, hearing from everyone and seeing that they were able to go through this. So if you do have any questions or feedback or anything, let me know in one of the channels I talked about. Thank you again, everyone. I'm going to go ahead and end the broadcast now. And hopefully I'll talk to some of you later.